Hey, gun people, I'm here with Buck, my master instructor, and he makes suppressors. So he's gonna explain what happens when a suppressor, because I was asking him questions. So go ahead, Buck, explain that again, because this is cool. So what happens when you fire a gun?
Okay.
Oh, there's three things you said that's suppressing: heat, volume.
Heat, volume, and turbulation. So when you fire a round from a rifle, we'll say this is the threaded portion of a suppressor. What you're seeing here is basically a short stack of a suppressor minus the tube. The tube is the thing that, of course, holds this thing together and has to withstand.
Has all the guts in it.
Has the guts. So my particular design enables me to make different parts. This is the threaded end cap. You're familiar with what it looks like. It's got the threads. It's got internal threads because my suppressors are made so you can take them apart. Now, once the gas exits the muzzle, it enters what's called the blast baffle or area expansion chamber, and it expands. It may be starting out at, say, 25,000 psi when it enters this first chamber here, but then it runs into a baffle. These are made of titanium and have a series of ledges that are machined into this primary surface of the baffle, and they cause ripples and turbulation in the gas, so that you got this flame pattern that comes out of the muzzle, hits this, gets turbulated, and because there's still a lot of pressure in here, we'll say it went from 25,000 down to 20,000, it says, let's get out of here, down through this hole into the next chamber, which has also some of the volume from the back side of the baffle, which I've taken out. The next chamber is approximately 3/4 of an inch.
And the spacer is for?
The spacer is to keep the baffles apart and to give me volume and for the gas to expand and cool.
Okay.
Now, this is a more of a standard type baffle. The sides of this are curved around the hole, which allows turbulation. The gases in all different directions are sent in a semicircular pattern, and they come up and they stay within the side of the spacer, but they get turbulated and then they go down through that. And they go, wow, we're thinking we're going to get out, and guess what? They run into another expansion chamber which has another baffle in it. And then they run through another expansion chamber, and they finally run into the end cap, which stops the gas from trying to flow directly and forces it to come out there. In total, what we're trying to do with a suppressor is to cool the gas and turbulate it, and to get it to slow down. In a 308, the gases exiting the muzzle are doing exactly the same velocity as the gases, or as the bullet is, roughly 2,800, maybe 2,900 feet per second, depending on bullet weight. So that's supersonic. The gas alone causes a supersonic crack. Now, now this is a mock-up suppressor. My actual suppressors are about 8 inches long. What they do is the gas expands, cools, and turbulates, knocks off the fire, so that there's no flame coming out of the end of the suppressor. There's also the gas has been slowed down from 2,700 feet per second to around 1,000 feet per second, 1,050. It's subsonic, so you hear more of a sound than you hear but that's on a subsonic bullet. On a supersonic bullet, you're still going to have the bullets coming out at, say, 2,700 feet per second. You'll actually pick up a few feet per second in a suppressor that you didn't get out of a standard rifle. Why? There's gas pressure that's continuing to push on the bullet, even though it's not contained by the rifling. So you'll pick up a little bit of velocity with a suppressor. The supersonic round will make a supersonic crack only from the bullet, because the gas is contained and is subsonic when it exits. Therefore, the rifle makes no noise, but the bullet's going to make a slight noise once it's past someone who can hear it, and then has the supersonic shock wave, which follows the bullet at roughly a 45-degree cone. There's actually one on the front and one on the back, but we won't get into that right now, but that supersonic shock wave sounds about like a bullwhip. Depending on the bullet diameter and the bullet velocity, determines how loud that supersonic shock wave is. I know for a fact that a 50 BMG supersonic shockwave is loud enough to force you to wear ear protection in the pits when you're scoring targets at 1,000 yards. The bullet's doing around 2,000 feet per second. I used that knowledge to save my life up in Alaska back in 98. I had 2 brown bears decided to have me and 4 other guys for lunch one day, and I said that's not a good idea. So I took my 50 BMG single shot LAR Grizzly and or big bore rifle, whatever they call it.
That one right there, right?
Yeah, that one right there, and I fired a tracer at the bears as they were charging about 200 yards away. They started at us from about 600 yards, and it gave me enough time to get set up and get my buddies up there and get their earplugs in, their bipods down, their safeties off, their scope covers off, and locked and loaded, ready to shoot bears. We were not bear hunting. We were not legal to hunt bears, but we damn sure we're not going to have the bears hunt us. So I put a 647 grain bullet into the dirt about 4 feet in front of the bears and about 2 feet right of his head. And the bullet tumbled, as I expected it to do, and it flew and tumbled right past the face of the smaller of the 2 bears.
Because it was a tracer, you could see.
Because it's a tracer, and tracers are notorious for becoming unstable. Why? They're filled with phosphorus. So you got a heavy-duty copper jacket, which weighs around 240 grains. This is not nothing, but it's nothing like the 650 grains it started with. So by the time it gets out there to 200 yards, it's burned off maybe 100 grains of the phosphorus. So it's unstable, and they tend to tumble. Well, it did, and it went right past this bear's face. Why was I using tracers? Because I wanted the bears to see something, not just hear something. So the larger of the 2 bears, which was around 12 feet tall, 1,200 pounds, decided he's going to circle around and flank us a little bit. I said, no, you're not. And at about 186 yards, he was still coming towards us. I loaded another round, put the crosshairs on his forehead, and fired a round right between his ears. In other words, the bullet went just above his head, about 6 inches high, and right between his ears. Now, this bear has a head the size of a wash tub. His eyes were the size of my fist, just about. Big, big animal. You don't want to mess with one of them like that. And I wasn't going to mess with him. I was either going to scare him or kill him. It's his choice. But the supersonic round is when he went back by the bear, forced him to, he closed his eyes.
Disoriented.
He grimaced.
Yeah.
His elbows went out as he ducked his head. He had never been hurt that bad in his life from a bullet that only
went by him.
Just went whistling by him at about 2,500 feet per second. The supersonic crack that close sounds about like a short barrel 44 Magnum held up next to your head. Somebody fires and says, "Did you hear that?" yeah, I think I heard that. When he cleared the horizon 5 miles later, he was still running. Yeah. That has nothing to do with suppressors, but it's a great story.
It is a great story. I love that
Talking
story.
about why we like suppressors. Now, you can take a 308 and put a suppressor on them. You take the supersonic rounds and reduce the noise volume by about 37 decibels, which is a significant amount of noise level. Outdoors, a full house 308 sounds about like shooting a 22 short. You hear it. Okay, and that's not too bad. Indoors, it's a little louder than that because we're hearing the supersonic crack of the bullet. You can always hear the crack of a supersonic bullet from a 22 on up through a 50 BMG. The farther you are away from the rifle, the less you're going to be able to hear. A bolt-action rifle with a suppressor, if it's well-made suppressor, you will not hear the gun fire if you're 50 yards away. You will hear the bullet snap. But the deal is that if Rick were to shoot at me or shoot at a target and I'm 50 yards down range, I wouldn't hear the bullet until the bullet got to about 60 to 65 yards. And where did the bullet sound come from? It came from the area towards the target. It didn't come from the
shooter.
It
right.
came from behind him. So that's what it really messes up with game because you can't figure what the heck is happening if you miss them. If you hit them, they don't get in their care anyway because they hear that sound when the bullet smacks the target.
So I ask you why the standard most houses I've looked at, they've had about 6 baffles.
Yeah, generally 5 to 7 anywhere. Some of them, I've seen some Surefires that had like 8 in there, but the
More baffles, the more quiet, but it adds weight, adds
not
distance.
necessarily more quiet. From a physical standpoint, the average suppressor that is effective has a volume equal to the internal volume of the suppressor is equal to 20 times the bore volume. Now that's the total volume of F556, and you can figure it out, multiply that. The area of a circle times the length of the barrel, and that gives you the number of cubic inches of that bore. Now a 308 bore is bigger, a 458 bore is bigger, so you have to have a bigger suppressor volume. That's why if you see a suppressor for a 50 BMG, they're generally about 2 feet long and about this big around. They look like a sewer pipe because
It's got to be 20 times the
20
volume.
times the bore volume of a 50 is a lot more than 20 times the bore volume of a 30.
Right.
So, now adding the baffles themselves have weight, the baffles have expense, and the baffles themselves take up volume. So these are different designs, and I weigh these and to see which one of these skirted baffles I'm going to like the best for sound deadening. I also do other things. I drill holes through them and cut and mill slots in them and try to change up the geometry on the faces of the baffles to enhance the turbulation. I've got books that tell about all these different suppressors designs and books on patents on different things.
So what do you think is more important for quietness out of the three? Volume, heat cooling, or turbulation?
Probably turbulation.
Oh, really?
If you stack up, this is just baffle on top of baffle on top of baffle. Well, the problem is, A, that's very expensive, and B, there's very little volume associated with that. By adding these skirts on there, you can see that I get a lot more volume by separating these.
Right.
And when I start stacking them on top of each other or separating them, than if I just stood them on top of each other. Now the purpose of the skirt, the skirted baffle design, is twofold. One thing, it prevents the gas from making contact with the side of the suppressor. Whereas this, when it's mated to an end cap, and actually 2 end caps, no gas escapes from these baffles and ends up inside my tube. Why is that important? Well, A, this is a strong design. This is basically what a lot of guys, when they manufacture a suppressor, they'll build it something like that, and then they'll weld all of these joints together, put this in a lathe and turn it off and slip it in a tube and weld the end caps on it and declare victory. Hey, we made a suppressor. I go, congratulations. The problem is, they're suppressors, you can't take them apart and clean them, ever, because they're, in fact, welded together. I'm not knocking that design, I'm just saying I like my design better because when I want to, I can take these, and I've approached this situation of how to get these things apart several different ways. I've got strap wrenches that will take this apart. I can put the suppressor in the end caps in a V-block and just turn on the tube, and unscrew the tube from one end to the other. I've actually turned facets on the outsides of some of them.
And you said this cuts costs. How much are your suppressors compared to?
Mine, my titanium suppressors run around $900. That's about $150 cheaper than some of the other suppressors that don't come apart. My aluminum suppressors for pistols sell for $400. My steel suppressors sell for $600. And most of that difference is in the cost of materials and then the cost of the tooling. Working with titanium is a bear. It's not for the faint of heart. Titanium is difficult to work. It requires really, really, really sharp tools, and because of the inherent strength in the material like that, it causes wear and breakage in the tools, much more so than steel. Aluminum is very forgiving to work with. I can get a really nice finish and take a sharp tool, and I can build 15 suppressors with one tool. I generally, like with my threading tools, I try not to use one surface more than on one suppressor. Turn it and use it on a different suppressor because it is imperative to keep the tools really, really sharp. And so that adds cost to the manufacturing.
We're at 15 minutes. I'm gonna wrap this up. Thanks, Buck. I'll put a link to some of his books. He's an author. He's written a lot of books, and he's just my go-to gun guy. So I'll put a link to his contact info in the description, and I'll slide it in.